Alright, in this video we're going to take a look at how you can graph a linear function, looking at what's called the slope-intercept method, and we'll take a look at all the steps involved first and then take a look at a couple examples. So your first step is you have to make sure that your equation is in functional form. That's y equals ax plus b, so you have your y isolated, everything else is on the other side of the equal sign. Sometimes people say y equals mx plus b. I've also heard mx plus c. It really doesn't matter what we call the letters. We'll look at what they mean in a second. And so if your equation is not in functional form, you're going to need to arrange it so that it is. Sometimes people have a hard time with that, so I've actually created a separate video that looks at putting an equation into functional form if it's not there. So if that gives you a hard time, it's something you might want to check out that video as well. All right, after we've got in functional form, then we're basically going to plot our initial value, which is the value of b, and that is your y-intercept. So it's going to be where the line crosses the y-axis. Usually an easy one to plot. After that, we're going to determine the rate of change, or a slope, two terms used interchangeably, and that's your a value, so the number before your x. And you have to make sure that if it's negative, that you take that into account as well, because that will change it. And from that, we're basically going to plot additional points. So we're going to start with our initial value on the y-axis, and then we'll plot additional points by moving either up or down, depending on whether we have a positive or negative rate of change. And we'll go up or down the number of units indicated in the numerator of our slope, and then to the right, the number of units indicated in the denominator of the slope. Now, if you have a whole number slope, your denominator is 1. You wouldn't normally write that in, so you just go up and down the number in your numerator, or the number that's shown in your whole number, and then 1 to the right. Similarly, if it's a decimal, we usually don't write in the denominator of 1, but in that case, you'd be moving 1 to the right as well. And once you've got a few points drawn, then you're just going to connect your points. Now, technically, to do a line, you only need to have 2 points, but I'm going to recommend that you actually use 3. So you can do 2 points to define your line, and then 1 extra point, and just kind of check it to make sure you've done it correct. All right, so let's take a look at one of these. We'll do it in red. So we check to make sure we're in functional form. We are. Y equals ax plus b. Again, our y is isolated. Plot our initial value. So our initial value in this case is plus 5. So we can go on to the y-axis. Plus 5 is right there. And then the next thing we have to do is we have to look at our slope. We'll do that in blue. So our slope right here is 3. And again, we'll notice that there's no denominator, so that's basically 3 over 1. So we're going to plot additional points, in this case by moving up 3. We're going up because it's a positive 3. And then to the right 1. Again, always going 1 to the right. So we start here, over 1, up 1, 2, 3. There's our next point. Over 1, up 1, 2. Oh, we're actually kind of off the graph there. If we went 1 to the left, which we could do as well, in that case we would go down 3. So we can get a couple more points there. 1 to the left and down 3. And then after we've got several points on there, we're just going to connect our points. So I'm going to grab a line here and connect our dots. That top one's off by a little bit. And again, depending on how careful you are with it, some of this might be off by a little bit, and that's to be expected. And there we go. Again, usually we put the little arrows at the end to show that the line could continue in all directions. And if you're really looking for some bonus points, it's also a good idea to label your line. In this case, because it's only the one line, it's not such a big deal to label it. If we had a bunch of lines on the same graph, though, you definitely want to label them all or do them in different colors. So there's one example. Let's look at another one quickly. All right, asked to graph this one as well. Again, still in y equals ax plus b format. This time a little bit trickier though, because we have a function. We have a fraction. Pardon me. I actually much prefer using fractions if you're going to graph it rather than decimals, because it makes it a lot easier when you're doing it with the slope-intercept method, because you can really just do the over and up, and it's pretty simple. No, the fraction actually doesn't make it any more difficult in that case. So in this case again, we're in y equals ax plus b format, functional form. We're going to plot our initial value. Initial value is 4. There we go, right there on the y-axis. And then our rate of change here is negative 2/3. So if we look at that, negative means we go down, so we're going to go down 2, and then it's always to the right when we're looking at the bottom. So down 2 over 3. So I'm going to start here, down 1, 2, 1, 2, 3 to the right. There's my next point. Down 2, 1, 2, 3 to the right. And if we went 2 to the left, we would end up going, negative 2 to the left. We did, my mistake, 2 up, and then we go 3 to the left. I'm going to say something that makes sense there, 2, 3. That will put us right there. And then, again, go back and connect our points. And again, if you notice that you did it and there was a point that wasn't on your line, then yeah, you should double check that, because that means you probably just made a little boo-boo someplace. Could be in plotting it or calculating. And there you go. Piece of cake. I hope that helps. And thanks for watching. Bye-bye. You've been watching Mr. E, taking the suck out of success.